So let's look at a real world example of how a piecewise function is applied. So right here, it's our diminishing returns and overfishing. Okay, so it's someone tracking fishing boats and how many fish they harvest. Okay, real life situation that takes place. If you are game warden or park ranger or whatever, those people. So you can see right here that from when there's 0 to about 500 boats, it's a constant return, right? Then from here, it switches. It becomes a diminishing return. We start less you're getting harvest, right? Or we're over harvesting and then it's coming back. So we have two functions here happening from 0 to 500. Well, 0 to 4, it looks like. Not quite at 5. From 0 to 4, it's the linear function. And then from 4 to 12, it's the quadratic function. Notice how they both say equal. The reason why they both say equal is because they meet at the same point. Does that make sense? They're not opposites. They're the same value. So if I plug in 4 to that equation, I'm going to get the same value if I plug in 4 into the other equation. Does that make sense? So I can use either one to evaluate 4. Okay. So what we have here is evaluate f of 6 and interpret your answer. So if I want to evaluate f of 6, which is saying 600 boats, right? If I have f of 6, 600 boats, what do I get? Well, which interval am I going to evaluate that on? The second interval, right? Because 6 falls between 4 and 12. So I'm going to substitute that in. I have -1/4 times 6 squared plus 4 times 6 minus 4. This gives me 36. 36 divided by 4 is 9. 4 times 6 is 24. Minus 4. -9 plus 24 is 15. 15 minus 4 equals 11. So this tells me that when there are 600 boats in the out and fishing, there's going to be 11,000 tons of fish brought in. That's the projected amount. Does that make sense? Okay, this one is going the other way. So on example B, it's saying, what if you want 6? Like, what if you want your output to be 6? Which equation would you use? Okay, so it's asking if I want my output to be 6, which equation would I use? So when I go to 6 up here, which equation does it hit? The second one, right? So that means that I would be setting this 6 equal to -1/4 x squared plus 4x minus 4. And that's what I would be evaluating. Yeah, we got to solve it. Yeah, not evaluate. We have to solve. I said evaluate, didn't I? Okay, this is a quadratic. Do you remember how to solve a quadratic? Exactly. We would have to either do our X box method or the quadratic formula. But the number one thing is, in order to solve a quadratic, it has to be equal to 0. And is this currently equal to 0? No. So to make this equal to 0, we would subtract 6 from both sides. So we're actually working with -1/4 x squared plus 4x minus 10. Okay. And if I didn't want to work with a fraction, how do I get rid of a fraction? Multiply by the what? The denominator. Multiply by my least common denominator, which in this case would be 4, right? I would multiply everything times 4 to get rid of my denominator. So now I'm left with 0 equals -x squared plus 6. Oh, whoa. Crazy pen? No. Plus 16x minus 40. And if I didn't want to deal with the negative, you just change the sign of everything. Multiply everything by a negative. And so now it's a simple situation. What multiplies to give me 40, but adds to give me -16? Say what multiplies to give me -4 and -10. That makes -14. 40, what? Can we think of anything that multiplies to give us 40, but adds to give us 16? Let's see. What are our numbers for 40? We have 1 and 40. We have 2 and 20. 3 doesn't work. We have 4 and 10. We have 5 and 8. That's it. So we couldn't do it quickly. That means that it leads to unfortunate quadratic formula, and I am not about to do it. But that's how you solve it. Quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, the yellow poster up there. Okay? You think you're gonna tattoo that on you? Just sing it. So we would use the quadratic formula to evaluate. Okay. But that's just building on to something that you should already know how to do. Quadratic formula is technically an Algebra 1 in all honesty. But yeah, and that's how you figure that out. So you determine which interval you're going to use and do whatever you have to do to solve it. Now, wouldn't it have been nice if it was on the first interval and we just had to do 2x equals 6 and we would have been done? But it didn't follow the first interval. It fell on the second interval, which requires you to pull out a lot of little things out of your brain. All right, that concludes 4.2. My plan was to give you some time to work on 4.1 and 4.2, but apparently we ran out of time. Tomorrow's quiz will be part 4.1 and part 4.2, just FYI. I told y'all I had a quiz on. Don't try me. I said we will have a quiz.